Good morning everyone. Today, I, Mr. Neeraj Upadhyay, is going to conduct your first mathematics class. So welcome to the DPS online class for the session 2020-21. Now, today I am going to start the first chapter and the name of the chapter is Real Numbers. Now, before starting this chapter real number, let me first of all recap whatever you all have studied in class 9 in the chapter number system, because this particular chapter is connected with the number system which you all have studied in class 9. Now, you all have studied in class 9 what is a natural number. So we can say that natural number is a set, or we can say that natural number is a collection of all counting numbers. So all counting numbers are called natural numbers, and set of natural number is denoted with capital N. All counting numbers up to infinity are called natural numbers. Number 2. Then we have whole numbers. Now what are whole numbers? Set of whole numbers is denoted with capital W. Collection of whole numbers is denoted with capital W. And what are whole numbers? 0 is included here, and along with 0 all natural numbers are included here. Or you can say this way, all natural numbers in that if you just include 0, these all numbers, this is a set of whole numbers. Number 3, integers. Now what are integers? You see, set of all integers is denoted with capital Z or capital I. Okay. Now what are integers? See, you have 0, and then after that on the right hand side you have all positive natural numbers up to plus infinity, and on the left hand side you have all negative numbers up to minus infinity. So these are integers. Number 4, we have fraction. Then next, number 4. Two by 3 is a fraction. What is the meaning of fraction? You have a slash in between, and on top of that you have an integer, and below that you have another integer. So this is called a fraction. This is a fraction. Minus 4 by 5 is a fraction. 1 by 2 is another fraction. Now, then apart from this, then we have numbers in square root, like square root of 2, cube root of 3, cube root of 25. These are the numbers which you all have studied in class 9. Now let us move ahead, and first of all, let us see one more thing. See, any number whose denominator is 0 is undefined in mathematics. Or we can say it's not defined. Okay. Then the second thing, suppose if you get a number like this, square root of minus 2 or square root of minus 3 or square root of minus 4, these numbers are not real. Why not real? Because square root of minus 4 cannot be written as plus 2 or minus 2. It cannot be written as plus 2 or minus 2, because what is minus 2 into minus 2? It's plus 4. What is plus 2 into plus 2? It's plus 4. So you can, I see here we find that square root of minus 4 does not bear any value, does not bear any real value. It's proper term to use, like that square root of minus 4 does not bear a real value. And exactly same way, square root of minus 2, square root of minus 3, square root of minus 1, and so on. They do not bear a real value. Now, let us come to the topic real numbers. Now, in order to understand in detail about a real number, I'll show you one classification with the help of tree diagram. Now, so on the top of this tree diagram, you find that you have a complex number. So what is a complex number? Set of all real numbers and imaginary numbers are called complex number. But I haven't explained you what is a real number, what is an imaginary number? Now, any number under square root, please make sure that under square root, not under cube root. If it is negative, these numbers are called imaginary number. For example, square root of -2, square root of -4, and so on. So here the number which we are talking about in the last, like square root of -2, square root of -3, square root of -4, they don't bear any real value. They don't have any real value, and that's why these numbers are called imaginary number. What is a real number? Now, the one which we discussed here, except these two things, except the number where the denominator part is 0, which is called undefined, and the second part where if you find in square root any negative number, which is called imaginary number, except these two cases, all numbers which we have studied are called real numbers, sorry. They are called real numbers. Okay. So what are real numbers? All natural numbers, all integers, all fractions, all numbers in square root, cube root. These are all, real numbers. But one more thing, is cube root of -27 a real number or imaginary number? It's a real number. Why? Because cube root of -27 is -3. It has got a real value. It bears a real value. But square root of -4, it does not have a real value like +2 or -2, something like that. Okay. So that's why this is not a real number. This is called imaginary number. But cube root of -27, which is -3, is a real number. Okay. So don't get confused with this too. I have mentioned that square root of negative number is imaginary number. Next. Now, real number can be further classified as rational number and irrational number. Now, what is rational number? Any number of the form a by b for b not equal to 0 is called a rational number, because if b will be equal to 0, then we find that that number is undefined, means they are not real. Now, rational number can be further classified as integers and fractions. Now, why integers I said? Why not natural number? Why not whole number? Because you know that if I represent all this 1, 2, and 3 with the help of a Venn diagram, we find that we have, first of all, we have integers. Then we have a whole number. Then we have a natural number, because you can clearly see that all natural numbers are whole numbers. Clear? All whole numbers are integers. Okay? All natural numbers are whole numbers. All whole numbers are integers. Okay? So we find that if I say integers, in integer we find we have included everything. Now, what are the things we have included in integers? We have included in integer whole number. We have included in whole number natural number. So that's why what I have done here is I have classified rational number as integers and fractions. Clear? Now, integers, so everything is included in integer, and fractions, okay, and fractions like 2 by 3, -2 by 3, -4 by 5, 1 by 2, these all are fractions. Now, I have also mentioned here, I have also represented here that after integers we have a whole number. After whole number we have a natural number, means all natural numbers are whole numbers, all whole numbers are integers. Now, fractions can be further subdivided as proper fraction and improper fraction. What is a proper fraction? It is a fraction where the magnitude of numerator, if you leave the sign part, the magnitude of numerator is less than the magnitude of denominator. And that's why this is the reason if you divide and express in decimal form, you'll find that the value of proper fraction will be always more than -1 and less than 1. Clear? Now, improper fraction. In improper fraction, you'll find that the magnitude of numerator, except, see, if you ignore the sign part, if you don't consider the sign part, how do we, differentiate between proper and improper? In improper fraction, the magnitude of numerator is greater than or equal to the magnitude of denominator. Equal to also. It can be equal, it can be greater than the magnitude of denominator. And in proper fraction, we find that the magnitude of numerator is less than the magnitude of denominator. And so that's why if you express in decimal form, you'll find that the value is more than -1, less than 1. And in improper fraction, the value is more than 1 and less than -1. It can be equal to 1, it can be equal to -1, but it cannot be between -1 and 1. Okay, everyone? Now, let us move ahead and discuss further, but before discussing further, let me once again summarize the whole thing. So, complex number. It is a set of all real numbers and imaginary numbers. Imaginary number, in short, you can study in class 10 that all negative numbers are imaginary number. Let's come to the part real number. All rational numbers, real number can be subdivided into rational and irrational. I have explained you rational, but I have not completed what is irrational. In order to complete irrational, I'll first of all explain you that all rational numbers can be, I'll move on to the next topic, that all rational numbers can be rational numbers and their decimal expansion. I'll move ahead with the next topic, rational numbers and their decimal expansions. Now what is this? Every rational number can be expressed in two forms. If I divide and express in decimal form, every rational number can be expressed in two forms. And what is that? Either it can be expressed in the form terminating, or the second part, non-terminating repeating. And every irrational numbers can be expressed in the form non-terminating and non-repeating. What do you mean by this? And after explaining this part, I'll again come back to the tree diagram part and I'll explain you what is irrational number. Now, what is a rational? Now see, as we know that a rational number can be either expressed in the form terminating, okay, or non-terminating. But non-terminating, what type of non-terminating? Repeating. What do you mean by non-terminating repeating? After decimal, you will find that a particular set of digit will repeat every time. A particular set of digit will repeat every time, like 1.232323. You're finding that a set of digit is repeating every time, okay, is repeating periodically, and it goes up to what? Infinity. So I can represent this in the form 1.23, and on top of that I can give one bar. So this is the meaning of non-terminating and repeating. What is the meaning of terminating? Like suppose we have 2.5. 2.5 means after decimal you can find that after decimal this particular value terminates. But here you are finding that after decimal this particular set of digit is repeating periodically, means it is continuously repeating. And what is that set of digit which is repeating? It's point after point, 23, 23, 23, and so on up to infinity. So this can be represented in this form 1.23, and on top of that you can give one bar. Terminating means after decimal it terminates. Now what do you find in irrational number? In irrational number you find that, like here we find that a pattern is clearly determined, means repeating, means it is in which form? It is in the form that a particular set of digit is repeating every time. But in irrational number you will find that a particular set of digit will not repeat itself. Suppose you have after decimal 2, 3, 1, 4, then it can be 7, it can be 9, it can be 1, it can be 4. Means you cannot predict, you cannot determine the pattern. Means you will not find, as in non-terminating repeating in rational number, you will not find a particular set of digit which will keep on repeating. Now, so can I say that 22 by 7 is a rational number? Yes. Can I say that 1 by 3 is a rational number? Yes. Is 1 by 5 a rational number? Yes. Is 2 by 10 a rational number? Yes. It's both same thing. Is 1 by 25 a rational number? Yes. Now, but the thing is that what kind of, if I say, is this rational number a terminating or non-terminating repeating? Now let us see. You can divide this particular number. You can divide this particular number by using long division. Like let's take 1 by 3. If you divide 1 by 3, you have 3 3s are 9. 3 3s are 9. You are finding that a particular set of digit is repeating itself. If you divide 1 by 5, you are finding that 1 by 5 can be written as 0.25. If you divide 1 by 5 can be written as what? 0.2. Suppose if you divide 1 by 4 and if you express this in decimal form, you have 0.75. So here you are finding that digit terminates. the decimal expansion terminates. Here you are finding that the decimal expansion of this rational number terminates. But here you find that it does not terminate. Now I'll explain you how to identify without division, okay, how to identify whether a particular rational number will terminate or it will non-terminate and repeat. It will be non-terminating and repeating. How to identify? See, if any rational number in its simplest form, any rational number of the form a by b for b not equal to 0 in its simplest form, or we can more specifically we can say that a and b are co-prime. If suppose denominator, if denominator that is b is factorized, if b is factorized and suppose b is expressed in the form 2 to the power m into 5 to the power n, where m and n are whole numbers, then we can say that it is a terminating decimal. But if b cannot be expressed in the form 2 to the power m into 5 to the power n, where m and n are whole numbers, then it is non-terminating and repeating. Like we have seen here in these three examples, like 1 by 5. If you see 1 by 5 is in its simplest form, and if you factorize denominator, we find that the factors of denominator are, the prime factors of denominator is not other than 2 and 5. Means you have to compare with the prime, after factorizing the denominator, you have to check whether the denominator is factorized into prime factors of 2 and 5 or not. If you find any other prime factors like 3, or if you find suppose 7 or something like that, it means that it is not a terminating. So here I find that 1 by 5 can be written as, 1 by 5 is in simplest form, and 5 if you factorize it is what? 5 itself. So you find that you don't have prime factors other than 2 and 5. So we can say that it is a terminating decimal. But suppose if I say 1 by 3, 1 by 3 is in its simplest form. And if you factorize denominator, 3 cannot be further factorized. Now you find that denominator contains factors, prime factors other than 2 and 5. If it contains prime factors other than 2 and 5, we can say that it is a non-terminating repeating decimal. Now let me give few more examples. Like we have 23 by 45. Now is this in simplest form? Yes. Find out its HCF. Or if you factorize numerator and denominator, you don't find any common factor. Now this is in its simplest form, and if you factorize the denominator part, you have 5 into 3 square. Now tell me whether this particular fraction is a terminating decimal or non-terminating repeating. Can you tell me what type of decimal expansion you will have? Terminating type or non-terminating repeating? It's very much clear that denominator contains factors other than 2 and 5. So that's why this is not a terminating. So what is this? It's a non-terminating repeating. Now this next and the last part which I am going to explain you all today is how to express any terminating fraction into decimal without division. Let's take suppose 1 by 2 square into 5. What you will do is, as you all know that when power is same, as you all know that when power is same, base gets multiplied. So our objective is to make denominator equals to what? 10. 10 square, 10 cube, 10 to the power 4 and so on. So how to make, just see what is the power of 2. But make it sure that this method which I am showing is the only method which will be used to express a terminating, and you know how to check whether that particular fraction, that particular rational number is a terminating or non-terminating repeating. As you can clearly see that the denominator does not contain prime factors other than 2 and 5. So that's why we can say that it is a terminating decimal. How to express any terminating, rational number, okay, terminating fraction into decimal form? Let us see. So in order to express, what you have to do is check the power of 2 and check the power of 1. Power of 2 is 2, the power of 5 is 1. What is the highest power amongst 2 and 5? It's 2. So what you do, in order to make the power of both the factors 2 and 5 equal, what I need to do is, I'll be multiplying numerator and denominator both with 5. I'm going to multiply numerator and denominator both with 5. So as you multiply numerator and denominator both with 5, as you multiply numerator and denominator both with 5, you have in the denominator 2 square into 5 square. You find that the power of both the factors is same. If power is same and if you have product sign in between, base gets multiplied. So you have 10 square. 2 5 are 10, 10 square. You can write 10 square as 1 by 100 and this can be written as what? 0.05. One more example I'm going to give, and this is the end, and after this we'll wind up today's topic. Now let us take 1 by, suppose let's take 2 cube into 5 to the power 4. Now first of all tell me whether this particular fraction is a terminating or non-terminating repeating. It's clearly visible that it is in simplest form, and now you find that the denominator does not contain factor other than 2 and 5. It contains factor 2 and 5 both. Then we can say that it is a terminating. How to express without actual division? How to express any terminating? This rational number into decimal form. Let us see this now here. One more example. Now, if you check the power of 2 and power of 5, which is greater, it's 4. Means what I have to do is, I have to make both the power of 2 and 5 equals to 4 here. To make the power of both 2 and 5 equals to 4, I need to multiply numerator and denominator both with 2. Okay. Then we have 2 by, as you know that power is same and base power is same, and you have in between multiplication sign. So can I say that base gets multiplied? So we have 10 to the power 4. So we have 2 by 10 to the power 4, which is 2 by 10,000, okay, which can be written as 1 2 3 4 1 2 3 4 decimal. Okay, so this is a way how we can express any terminating rational number, any rational number which is of the form terminating in decimal form without actual division. So this is the end of today's introduction class of a real number. In the next video class, I'm going to explain you Euclid's division lemma. Thank you.